Hi, I'm Dan Zenoble, and this is a little side project I've been working on that builds off of the robot from my previous videos. So I happen to have this desktop CNC machine here that I use for all kinds of fun stuff. Right now it's modded with a blade to cut vinyl stickers like the one on my window here, but it came with a 5.5 watt 450 nanometer diode laser for engraving wood or cutting cardboard. And I started thinking, how fun would it be to mount that thing on a robot? And thus was born the Ankle Zapper 5000. This little guy is capable of popping balloons or lighting matches at close range, and can be set for manual or auto targeting. It's not going to win me any defense contracts, but it was definitely a fun little exercise. I'll get into how I did it, but first, a reminder that lasers like this are not toys. They can permanently damage your eyes or start a fire if you're not careful. Always wear laser safety glasses when operating a laser, and always be aware of what it's pointing at. Do not point it at people or pets. I first removed the laser and its driver board from my CNC machine and mounted them using their pre-existing mounting holes. The driver board requires 12 volts, 2 amps, which I supply with a rechargeable battery mounted on the top plate. This driver also uses a PWM input to control the laser power. This input receives signals from one of the Raspberry Pi pinouts so that I can have it on constant low power for targeting and only a brief spike to 100% power for when it actually fires. While testing this out, I discovered a problem. The driver board requires 5 volts on the PWM pin, while the Pi pinouts are only 3.3 volts. I would have to step up the voltage somehow. Luckily, I happen to have an S8050 NPN transistor lying around, which I used to make a 1 transistor level shifter to achieve just that. I connected the base to the Pi's pinout with a 1 kilo ohm resistor, the emitter to the Pi's ground pin, and the collector to the Pi's 5 volt pin and the laser PWM pin through a 10 kilo ohm pull-up resistor. The way this works is, whenever the Pi's PWM output is high, the transistor turns on, connecting the collector to ground and giving a low output to the driver board. When the Pi's signal is low, the transistor turns off and the pull-up resistor pulls the output to the required 5 volts. Therefore, we get a 5 volt inverted version of the 3.3 volt PWM signal coming out of the Pi, which can be used to control the laser's power. For the code, I mostly ripped off of my previous assignments involving object tracking and teleoperation, and just added the laser functionality. I initialized pin 17 as the laser PWM output with a frequency of 1000 Hz. The duty cycle is inversely proportional to the laser power due to the level shifter, so I set the duty cycle to 255 for low power targeting and bump it down to 1 for zero point 0.1 seconds when I want it to fire, which I do by pressing L on my keyboard. Targeting isn't as simple as just centering the target in the camera's view. The laser is in a fixed position offset from the center, so an offset angle is required to get an actual bead on the target, and this angle varies with distance. Also, for maximum effect, the target needs to be at the focal point of the laser, about a foot away from the lens. To account for this, I placed a square reticle on the screen centered over where the laser should appear when at the correct distance. In teleop mode, I can just move the robot until the laser point appears within this reticle, and I'll know I'm at the right distance. For the auto-targeting mode, I just updated the code to align the center of the target with the reticle instead of the middle of the screen. For future development, I'd really like to improve the auto-targeting. Right now it relies on already being placed the correct distance away. If I can use HSV masking to track the laser dot, I can have it autonomously adjust position until the laser dot is within the targeting reticle. The challenge with this is how the laser changes color and brightness based on what it's reflecting off of. The other issue I'd like to fix is that it can't aim up or down at all, hence the name Ankle Zapper. Its effectiveness is confined to a plane about ankle height off the ground. I'd like to use a servo to get it to move up and down. That's all I've got for now, but thanks for watching. Hopefully I can continue to work on this and provide an update soon.